Hello everybody and welcome to the 20th C tutorial, and today we will be looking at bitwise operations. Now, what are bitwise operations? Bitwise operations are operations on bits. Now, you know that basically everything on a computer is encoded in zeros and ones, so we can manipulate those zeros and ones in interesting ways using bitwise operations on bytes. So if, say for example, we had a char, that would obviously be 8 bits. Let's say that's 7. So that, like a char could be that. Or just that. Yeah, I've been a bit tired today. Again, bloody mocks. So yeah, that could be that. So what these bitwise operations work on are on these bits and switch based on the operations, and I'm going to show you a couple of those operations today. First of all, we will start with and the and in C is on with an ampersand. Now, how it works, let's say we have the number 64. It's a lot easier to separate these into nibbles, I find, before you write them, because then you know for definite that there's 8, and it doesn't confuse you with encoding, because you know it obviously goes to 1, 2, 4, 8 on a nibble, then 8. So yeah, then you got 16, 32, 64, 128. It's just quite easy it's better to do them in nibbles really, but I'll do them as nibbles and then do that. So let's say we do the number, I don't know, say 120. Let's say, yeah, why not 120? Because it's a fucking difficult number, I imagine. So yeah, so that's quite a difficult number. Yeah. Probably that's. I know you didn't come here to watch me do this, but I'm doing it anyway. So 64, 32, 98. Plus 16 goes 114, plus 8 goes 122. So we want to get rid of that and replace it with that, and yeah. You don't really use this much in C unless you're working on embedded systems and you're doing something quite complex, like say writing an operating system for a original 386 or something. So don't worry about this unless you're doing the assembly tutorial, when it is actually really integral to learn this. So, and how and works is there has to be a digit there. There can't just be 1, there has to be 2. So our result is boom. So if we and together 64 and 120, we get 64. Now there are other operations as well. This will probably be one of the longer tutorials because it's a lot of theory. So yeah, I'm not going to go through not, because I think that's one complement anyway. So yeah, you can look up a not, but I don't think there's an operation for that in C. They can probably muck around with stuff and do that. There probably is. I've never really counted it in a lot of the books that I've read. So let's go on with inclusive OR. Essentially what inclusive OR means is that you can either have 1 or 2. So if there's a bit switched on either of the values in a given position, you can in fact have that, and that'll becoming the resultant like there. So let's take these numbers for example. Yeah, it's more handy to write them in nibbles. I know I did them the other way around this time, but heck. You see, I prefer doing them in hex. Well, I prefer hex, but obviously to properly explain to you how these work, you have to do them in binary, because that's how they work. So if we did inclusive OR on this, note this here, which is done by pressing shift slash, is the OR operator, inclusive OR operator. So what we get is because there can be 1 or 2. See? And for the third one, there's a couple of them. And what this does is it is exclusive or, which essentially means that you can't have 2, there must be 1. So if we repeat these numbers again, note there is a different operator for this, and I will remove that. So shift 6, that is the operator for exclusive OR, and what we get from that is 0, 0, 1, 1, 0, 1, 0, 0. You see there's 2 there, so exclusive OR means they're turned off. Yeah, and so that's basic ones, but there are 2 that are very useful, especially in assembly language or in a very low system, because it definitely takes less memory than using a multiplication or a divide operation, because they take a number of cycles, and if you're dividing by factors of 2, you might as well not use them because it's faster to shift. And first we have right shift. No, that's left. And what this does is it shifts the number left, so I'm just going to have 1 bit switched on for this because it demonstrates the idea better. So let's say we want to shift this once. So then we go across and it's 0, 0, 1, 0, 0. See? It's bit shift. You can do this as many times as you want. So this is an equivalent to a divided by 2. So obviously that's 64, now it's 32. Then we also have left shift, and that's obviously the other way around. If we were to do that with 1, you would get, which would be 128. And last but not least, we have something called 1's complement or something. I can't remember exactly what it's called, but essentially what it does is it switches the values. So if we have the number, let's use this one for the sake of being interesting. I'm not going to compile it this time because I think it's quite a theory heavy lesson and I don't want to make them too long. So if we do 1's complement, which is that, I understand, what you do is you flip all of the bits, so that goes 1, 0, 0, 0. Yeah, 1, 0, 1, 1. Because you see, it switches the bits. I've never used 1's complement. I only just found out about it because it doesn't talk about them in many books. But that's how I assume you use it, because it doesn't seem to. It's a unary, so you probably would do it like that, because it's a unary operator and doesn't operate on more than one thing. Because of course, obviously, while left shift only works on 1 variable, you can obviously replace that with a variable name though. And that could be 1 or a million. Well, it couldn't be a million in standard C because obviously there isn't a variable that wide. So you get the rough idea of how bitwise operations work. You can do this with any variable, although to be honest there's no point doing it with floats unless you're somehow gifted with the ability to see how floating point numbers work in that way. I mean, they're a lot more complicated than integers and chars, and to be honest I think you may as well just use an integer for most things, unless of course you're doing quite scientific research on things like super colliders and things. So thank you for watching. This was probably a boring episode and I'm not sure why I teased you in the background with that. I think I was going to do an example, but I decided not to because it's already quite a long-winded episode and I thought maybe you could try it yourself, and well, it's always better to try yourself. Actually, that's a good point. I'm not going to compile the codes because you can run the code and see if it works. So thank you for watching and I will see you later. And also I'm going to be running a giveaway for a key to FTL Faster Than Light. FTL Faster Than Light is a game. I will talk about that in the video, which I'll probably be uploading alongside this. Thank you for watching and I'll see you later this time.